Alright, welcome back, students of MEFB 2013-213 manufacturing processes. So, we have completed the cold working process. So, before I move on, my first question, please think about the stress strain curve and how would you fit the hot working and cold working process in the stress strain curve. So if you remember when we spoke about the stress strain curve, the curve started off with an elastic limit where I told you that there will be no manufacturing processes that can take place because it's just like a rubber band. Yeah, when you stretch it and you let it go, the material comes back to its original position. So all shaping processes takes place after yield point, which is the plastic region. So after yield point, you have two regions. The region BC, where you have shaping without fracture. C is your ultimate strength of the material or the maximum strength of the material. And I told you that for you to actually cut the material or fracture the material, you definitely need to exceed the ultimate strength of the material, meaning that the force that you apply have to exceed the ultimate strength of that material. So you have the second part or second region, which is region CD, which involves shaping the material with fracture. So having said that, it's obvious that hot working and cold working process is shaping without fracture. So I would classify hot working and cold working process under the category of BC, shaping without fracture. Okay, so having said that, let's move on to the next manufacturing processes, press working operation. Okay, so what is press working operation? If you look at the definition, I would not require you to memorize the definition, just understand it. Yeah, so press working is cutting, forming and drawing of sheet metal materials using punches and dies. Okay, so you see these words repeating again and again. Yeah, cutting, forming, drawing. You've seen it, the same words. Yeah, these are the key words. Yeah, cutting, drawing, forming. You've seen these words appear in hot working. You've seen these words appear in cold working. You've seen these words appear in metal cutting. Yeah, so if you look at it logically, there's not only one method of manufacturing a product. Yeah, you have so many routes to manufacture the product. So as a manufacturer, you need to choose the right method. How do you choose the right method? Again, it depends on your budget. Yeah, depending on the type of industry you're involved, depending on the affordability, the cost involved, the equipments that you have. Okay, things like that will finally determine which process you choose to use. But otherwise, there are several routes that you could use to produce a particular product. Okay, so if you look at the definition again, yeah, for press working is cutting, forming and drawing of sheet metal materials using punches and dies. So just from the keyword there, you see the word cutting. So press working will have a normal forming and drawing where you need not fracture the material. So that is BC of the stress strain curve. And you see the keyword there, cutting. So once you see the word cutting, automatically you should realize that the material is being fractured. So that part of it, or that part of the manufacturing process, would fall under the category of CD. Okay, so punches and dies are your molds that are being used in a press working operations. Okay, so if you recall, there's several molds that were used here. In die casting, you hot chamber and cold chamber, you had the movable half, stationary half. In sand casting, you had the cope and drag. Okay, so similarly here in press working, we call it punches and dies. Shear forces. What is shear? Shear is cut. So in layman's term or in technical term, we call it shear. In layman's term, we call it cut. So shear forces are forces that are applied to the metal to be cut, formed or drawn. Shear strength. Okay, so the moment you decide or you want to cut the material, you always have an opposing force called a normal force. Yeah, so just like in real life, yeah, if somebody comes to punch you, you're not going to just stand there and say, okay, punch me. No, right? You're going to defend yourself. So similarly, all materials have the same characteristics. So the moment you try to fracture the material's normal force will oppose your action of trying to fracture it. So you generate a lot of frictional force, and you need that shear strength, yeah, or cutting strength to resist the material. So in press working, the shear forces must be greater than the shear strength of the material. Meaning that the forces that you apply to machine the material has to be greater than the strength of the material. Otherwise, or the ultimate strength of the materials. Otherwise, you cannot machine the material. Yeah? So remember, you need to exceed the force that you apply need to exceed the ultimate strength of the metal so that you can machine that metal. So again, what is a press? A press is a machine that is used in press working operation. Presses use tools called dies and punches to perform the press working operation. So a quick introduction. Yeah, so what are the advantages and the features of a press? So unlike machine tools, presses are flexible and multi-purpose machines, meaning that the press can be designed to fit in the mold for different types of operations, meaning that if you want to do blanking, you can change your mold accordingly. If you want to do bending, if you want to do drawing, you can change the mold, interchange the mold accordingly. That's why we call it a multi-purpose machine, because just by changing the mold accordingly, you can produce different types of products. You need not have to have different types of machine to do different types of operation. All operations can be done on one machine just by interchanging the punches and dies. Okay, so firstly, unlike machine tools, presses are flexible and multi-purpose machines. This is because one press can employ many interchangeable dies and punches. So like I just mentioned to you, you have your mold. Okay, your mold is called dies and punches. So every dies and punches, or depending on the operation, you just keep interchanging your dies and punches accordingly. So a standard press can perform different types of operations like forming, shearing, and punching. Presses are productive machines or used in mass production because for every one stroke, one part is produced. That is why presses have found a wide application in automotive, aircraft, and appliances industry. So a lot of the parts produced in this automotive, aircraft, and appliance industries are designed using a press machine. Okay, so what are the factors involved in the selection of presses? Before that, let's look at a press machine. So this is a typical press machine, and this is your dies and punch assembly. Yeah, so if you look at your press machine are made of several parts. So please don't go and memorize this. I'm just introducing you to the press machine. I expect you to visualize and understand, not memorize. Yeah, so just for your information, let's just quickly go through this press machine. Your press machine is made out of a ram. Okay, ram or the slide. You have a backup plate. Okay, so this is where your mold fits. Okay, so you have a punch block and you have a die block. Both have to come in pairs, not just a punch, not just a die. So your punch and die will exactly or actually determine the type of operation. So if you need to do a blanking operation, you need to have the right punches and dies attached to the machine. If you want to do a drawing operation, you need to fix the right punches and dies to the press machine. Okay, so besides that, you have all the other parts, and each and every part here plays a very important role in the operation of that press machine. Yeah, so you have guide post bushings, you have a punch plate, you have metal strip, blank, die holder. Okay, die holder is basically to hold your die. Okay, and the shank or the body, okay, is there. This is your shank, and then you also have a punch holder to hold your your punch. So remember, punch and die are your molds, your achuan, yeah? So you have a punch holder to hold the punch in place. You have a die holder to hold the die in place, okay? So that's how it functions. So if you look back, okay, the press working machine is made of dies and punches so that a standard press can perform different types of operations: forming, shearing, and punching. So because of its multi-purpose functionality, presses are considered very productive machines. It is used in mass production because for every one stroke, one part is produced. So presses have found a very wide application in automotive, aircraft, and appliance. What are the factors that are involved in selection of presses? I will explain all these factors later, but just as an introduction, there are 4 factors of selection of press. So when you select a press, number 1, you need to know what is the operation type. What are you going to use this press for? Are you using it for a drawing, for a bending, for an extruding, for a blanking? What are you using it for? Number 2, size of part. Is your size of part big, small, medium? Okay, what kind of size of part are you expecting? Required power. How much of power is needed? So depending on the type of operation, the power will be varied. And number 4, the speed of operation. Yeah. So this is your press machine. Okay, so how do you rate your press, or how do you measure your press? Press rating is given in tons, okay, and it's also called a tonnage rating, and it's the energy spent on the work at each stroke. Okay, so there are different types of presses. Like I told you, your presses can be classified according to the power source, according to the operation type, according to frame type, okay, and there are other types of presses which we will discuss in this chapter. Okay, so for this slide, I would like to stop here. Okay, I'll continue further. This is a basic introduction to press working. I would like to continue further in the next class. Thank you very much. Have a good day.